David Smith here with one more Flipped Classroom math video. 3 tips before we start. You could turn on the captions and watch my words go by on the screen if that helps. You could also speed up the playback if you can get through the video faster and still comprehend. Lastly, you could pause video at any time and catch up on your notes. Today's topic is domain and range. And these two words are very precisely defined, and understanding those definitions and how they apply to functions is essential for a certain type of IB questions that you're going to get about functions. They're going to ask you to describe the domain and the range and the limits thereon, and you've got to understand how that works. This is sometimes critical thinking type problems that require you to think about functions in very specific ways. So first, let's take a look at the definitions. So the domain is all of the possible values in the first set of the function. Now, the way you can think of a function is that it's 2 sets of values. So the first set of values is all the x values, and the second set is all the y values. So in a way, we could talk about every function as 2 sets, all the x values and the y values. So the domain is all the possible values in the first set, which are the possible x values. Okay. Now, if we take a little bit of a shift over to science, the domain is also what we call the independent variable. And this is the one where we pick the number. If we're doing an experiment, we choose the independent variable and it determines the dependent variable. In math, in a function, we choose x. We choose the value of the domain that we put into the function, and then the function changes that value, kicks out a y, which is the range. So the range, the first definition point here, is just like the domain. This is all the possible values in the second set of the function. So that's all the possible y values. Finally, this one is called the dependent variable. So the domain depends on the range. So you can see these two things are interrelated. In fact, you have to analyze this at times to figure out what this is. Okay, so let's break that down and take a look at a few examples. Okay, here's a super simple function. It just has 4 different ordered pairs. So when x is 2, y is 3, when x is 5, y is 1, when x is 7, y is 5, and then 9, and then 5. So I know I kind of already gave it away. I said this is a function because indeed it is, but take a look at that for a minute, pause the video, and see if you can say why that's a function. How can we say it's not more of a relation, which is the more general term? Okay, so if you noticed that each x makes only one y, you're good. We don't have, say, another 2 over here that's making a 5, because then 2 would make 3 here and 2 would make 5 there, and that breaks our rule for a function. So this is a function, great. So now we're going to be asked to state the domain and the range, and I'm going to use set notation to do that. In this case, the domain is just these 4 numbers. So I'm just going to write my curly brackets and go 2, 5, 7, 9. And then my range is the same, but these 4 values, so curly brackets, 3, 1, 5, 5. So this is a pretty simple function, just illustrating the 2 sets and then how we might notate those using set notation. Okay. Here is another relation. It's making ordered pairs, so we're not yet saying whether it's a function. I'm using the mapping diagram to do that. So what I want you to do is pause the video and answer this question. Is it a function or not? Okay, so pause the video, take a close look at that, and answer the question. Okay, if you got yes, you are correct. There's only one value for each x. Okay, so 7 doesn't make both 4 and 8. 7 only makes 4. -3 only makes 4. It's okay to have 7 making 4 and -3 making 4. because that doesn't break the rule. It's only if -3 made another number as well as 4 will we break the rule. Okay, so this is a function. Pause the video. I want you to write the domain and the range. Okay, this is still on the simple side. Here's my domain, all 4 of these values. I've got them in my set notation. Here's my range, all 3 values. I've got those in my set notation. Okay, one last one. Now I'm showing you this relation in set notation. It's these 3 ordered pairs, 3, 5, -1, 9, and 3, -5. So we just have 3 elements in each of the 2 sets, the x values and the y values. So what I want you to do is pause the video and take this all the way through. First, answer your question, is it a function? If it is a function, then go ahead and say the domain and the range. So pause the video, give that your best shot, and then start it back up. Let's see how you did. Not a function. 3 makes 5 here, but 3 also makes -5. So this breaks the rule. For each x, there is only one y. This x, which is 3, makes a 5, but the same 3 makes a -5, not a function. So that's no, and we don't need to go into the domain and the range. Okay, let's get a little bit more complex and answer these questions for some graphs of some functions. Okay, and graphs are actually pretty helpful because visually they show you lots of stuff. Okay, so let's check this out. Here's a function. We've got very little information. We know its shape. Okay, so think about that for a minute. What kind of function is this likely to be? If you answered quadratic, you're right. This looks like a parabola that's a downward opening parabola with a vertex at the point 0, 6. Okay? Now, is this a function? Pause the video and answer that question. Okay, if you remember your vertical line test, as long as you can draw a vertical line that does not intersect the function in 2 places, or 3, then you've got a function. So it passes the vertical line test, so this is indeed a function. Okay? So now this is a little bit more tricky. What is the domain of this function? So what we're asking is what is the range of possible values that can go into that function? Are there any limits for the x values of this function? Or we've got our x and our y axes like that. So I want you to pause it and think real hard. Is it possible that we could have any value for x, or are there some limits? Okay, any value for x. This function, if it's some kind of quadratic, there's no limits on what x can be. X can be 0, x can be 1,000,000, x can be a fraction, x can be pi, x can be anything that's a real number. No imaginaries, but anything that's a real number. So we can use set notation and write the set of all x such that x is an element of real numbers. Okay? Now that's set builder notation. It's very descriptive. It reads the set of all x such that x is an element of real numbers. Now there's a much nicer way to do that that's nice and quick. We can just go like this. -infinity and then infinity. So that means that x can basically be anything. It's limited by -infinity. You can never you can't like put infinity into a function, so it can't be infinity, but it's limited by -infinity on one side and positive on the other. Now there's one more notation way for that, and that's that if you want to do square brackets, you can do it that way with -infinity and then positive infinity. And these are weird square brackets that face outward. So facing outward means it does not include that number. Okay, so set builder notation, parens, or square brackets. Now the book says square brackets are best, and I think that's good. We can adopt that standard in class. But if you use either of these notations, as long as you do it right, you're going to get your points. Okay, now the range. This one's a little different. Take a look at your graph and decide if there are any limits on the range. Okay, check it out. It's never going to be bigger than 6. I mean, you can see that. It's going through y equals 6 right there, but the parabola goes down on both sides of that. It's never going to be bigger than 6. Can it be 6? Yes, it can be 6. That's a solid dot. So we can write the set of all x, or I'm sorry, is the set of all y such that y is less than or equal to 6. Now, if we use one of these notations, we can go like so. We can do negative infinity like this, comma, and then we can do 6. Okay, so that says it's never going to be negative infinity, but it includes 6. Notice how my brackets are going the opposite way. You can also do it like this, just like so, negative infinity, comma 6, like that. Okay? So that's our first function. Lots of notation here. Once you get it, it's not so bad. But in the beginning, you're going to want to check your work, make sure you've got it right. Okay, now let's take a look at this function. Same thing. You've got a nice graph. You've got enough information to say everything that you need. You just have to pull it off the graph. Now let's take a look at that graph. Think about what kind of a function you might be looking at. Okay, periodic functions, if you remember from our trigonometry, tend to make graphs that oscillate, that go up and down between certain values, things like that. So this is some kind of a trigonometric function, probably a sine function, but we don't have the actual function itself, we just have its graph. So first off, is it a function? Yeah, it's going to pass the vertical line test. There's no vertical line that will pass through the function more than one time. So we know it's a function. Now I want you to think about the domain, the x values. Remember, this is the x-axis. So what possible limits can we have for the x values? So just think for a minute about that. Okay, I don't see any limits. We can have, this arrow is going to keep going, it's going to keep oscillating forever to the left and to the right, which are the x values. So there's no limit here. So this is going to be the same thing, the set of all x such that x is an element of real numbers. That's the same as this. Remember, it's not inclusive of infinity. It just goes right to infinity. Now, think about the range of this function. This one's a little different. So take a look at what the graph does and think about what is the range. This is the line y equals 2, and this is the line y equals negative 2. So the function is oscillating, going back and forth between this value for y of positive 2 and this value of y for negative 2. So think real hard. What is the range of this function? Okay, I'm going to start with set builder notation. It's the set of all y such that negative 2 is less than or equal to y, which is itself less than or equal to 2. Okay? So there we go. That's the range of this function, and we can also write that like this. Square brackets facing inward, negative 2, comma 2. Okay? Let's talk about an interesting, kind of weird type of a function. This is called a piecewise function. And really what it is a function that has two different rules. So for certain values of x, there's one rule that governs what the y is. And then for another range of values of x, there's another rule. And they make kind of weird graphs. So this graph is a piecewise function, and you can kind of see it. Whatever's going on with this part of the function, there's one rule that's governing that line. But then when we get over here, there's obviously a different rule. We've got a gently curving or increasingly steeply curving line going up in the y direction. So this would be a piecewise function. So we could write a rule for this and we could write a rule for that. It could still be considered as one function, but for different ranges in the domain, the x values, you have a different rule. So you can have a piecewise function with 3 rules, 5 rules. In this case, we just have 2. So when you have a graph like this, you can analyze the domain and the range, just like you normally can. But first, let's ask that question that you're going to be asked in the exercises. Is this a function? Is there a vertical line that we can draw through that graph that's going to touch the function in more than one place? Now, you might be tempted to say, well, what about right here? What about at 0? but you can see that this function isn't happening at x equals 0. Okay, it gets right up to it, but that circle is open, so that indicates that we don't have a value there, and that circle is closed. So really what we've got is a function that's going negative, not inclusive of 0, and then a function is going positive this way, inclusive of 0. Okay? All right, so answer is yes, it's a function. Let's take a look at the domain. So the way to think about that is ask yourself, are there any limits on the domain? Are there any values that x cannot be? So take a look at that. What do you think? I don't see any limits. It goes as far that way, that's the x value to the left in negative land, and it goes as far as it wants that way as it's increasing faster and faster in positive land for x. So this is going to be the set of all x such that x is an element of real numbers, and we can write that like before, like this. Whatever you would like. Okay, if you do it this way, just make sure you get it right, but this is just fine. Okay, so turned out that the domain, the x values, that's pretty easy. There's no limits. It can be anything it wants. How about the y values? Are there limits on the y? So take a look at our graph and see what you think. Okay, let's take a look at the range. Now this one is a little complex on the range. So buckle your seatbelt, tune in, pause the video if you need to catch up on notes or think about it. So check this out. We have, I added this here for this line. This line is a horizontal line going through the point 0, 1. So we know that the rule governing this part of our piecewise function is y equals 1. That's pretty straightforward. So I can start with my set builder notation like this, the set of all y, such that y equals 1. Okay, that's cool. Now, this rule doesn't form a continuum with this rule. In other words, we have this gap between y equals 1 and y is greater than or equal to 4. So what we do with this is we would write and y is greater than or equal to 4. And that would be our set builder notation for this function.
Now that you've watched the video, take a moment to write down any remaining questions so you can bring them to our next class. Also, remember that you can come back to this video, watch it again if you want to deepen your understanding or fill in any gaps. Lastly, if you enjoyed yourself, please click like or subscribe.